Hello, this class is going to focus on feature selection. Okay, so far we have always worked with all the different features that are provided in a data set, and so in this class what we're going to be looking are approaches that allow us to identify what features might be most relevant in a classification setting. Why is feature selection important? Where basically not always having more features is better. And we've seen that oftentimes when we were running experiments in which, having too many features actually increased so much the variance that the final error in the model was much higher than the ideal. Okay. And so applying feature selection prior or together with the development of machine learning models is important because on the one hand it might help to reduce overfitting, okay, and thus we might be increasing accuracy. It might also help us reduce the complexity of the model. So maybe we have a similar accuracy, but we have a much smaller number of sample of features, and so it's much easier to interpret the model and the outcomes of the model. And then finally, when we talk about feature selection, if we reduce the number of features in our model, generally it's also faster to train and test the models because, computationally it's less expensive. Before we continue, I'd like to clarify that sometimes when you look for feature selection online, sometimes there's a confusion in terms and sometimes they are used similarly when they are not exactly the same. And so when we talk about feature selection, we are exclusively talking about the fact that we eliminate from our data set specific features. Okay, so if we have a matrix with rows being the data points and columns being the features, we're going to eliminate or just not consider some of those columns. Okay. On the other hand, dimensionality reduction is also oftentimes used for feature selection to reduce the complexity of the features that we are considering. However, dimensionality reduction modifies or transforms the feature that we are considering into a lower dimension. Okay, so basically we are working with a different feature space that is similar to the first one, but that is simpler, is smaller, it has a lower number of dimensions. Okay, and so dimensionality reduction can also be used as a feature selection approach, but it changes the feature space, and so we won't be able to talk about the specific features. So it adds some, or it reduces the interpretability of the model because we are working with newly defined features that are not always easily interpretable. When we talk about feature selection, there's like two broad types of feature selection approaches. We have the univariate feature selection approaches and multivariate. Okay, the univariate are the simpler approaches, and they're also known as filter methods. And these feature selection approaches basically just focus on understanding what's the relationship between each individual feature and the final label that we are trying to classify or regress on with the machine learning model, but it basically ignores the machine learning model itself, right? So it's just the relationship between the features that we're working with and the labels. On the other hand, the multivariate feature selection, it basically looks into the interaction of the features with the machine learning model. So the selection of the features is not done just by analyzing the features themselves, but also by analyzing how those features interact with the machine learning model that we are testing. For multivariate, we're going to be looking into two different types of methods, wrapper methods and embedded methods. Wrapper methods basically select subsets of features and then they run those subsets of features through the machine learning model, and the subset of feature that provides the highest accuracy is the one that's selected. On the other hand, embedded methods are just feature selection approaches that are run as part of the training process of the machine learning model. Okay, so rather than first selecting subsets and running them through the model, we just learn the importance of the features as we build the model.